Good evening, students. Today we're going to learn about factors and divisibility. Tonight's video goes along with lesson 5.2 in your textbook. Go ahead and write the title for this lesson on the top of your notes. For your notes, you should have a sheet that your teacher gave you that you will be filling in as we go through this lesson. If you don't have that sheet, look on Canvas. It is there for you to download, and you can print it and complete it as well. Remember, our unit learning goal is how do patterns help me find factors and multiples? In this lesson, we're going to focus on how you can tell if one number is a factor of another. Before we begin, remember that a factor means simply a number that we multiply. From yesterday's lesson, we know that we can find factors with a model. For this problem, we could draw a model to find the answer. Students in Carlo's art class painted 32 square tiles for a mosaic. They will arrange the tiles to make a rectangle. How can they arrange 32 tiles into 3 equal rows without gaps or overlaps? The question of this problem tells me that I want to arrange 32 tiles into 3 equal rows without gaps or overlaps. So that means I'm going to do 3 equal rows, 1, 2, 3, and arrange the tiles in that manner till I get to 32. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. In my model, my last row does not have 3 tiles in each row. There would have to be a gap. So to answer the question, can a rectangle have 32 tiles arranged in 3 equal rows without gaps or overlaps? I have to say that that cannot happen. So a rectangle cannot have 32 tiles arranged into 3 equal rows. A much quicker way to solve this problem would be to use divisibility. You can use divisibility to see if 32 tiles can be arranged into 3 equal rows. Divisibility means that a number can be divided into equal groups with no remainders. On your note sheet, please copy down now the definition for divisibility. Pause the video and then play when you're done with that definition. Take a look at this number, 356,821. Just looking at that number, do you know if it's divisible by 2 or 5? How about 10 or 3? 9 or 6? By the end of this video, you'll be able to answer all of those questions in the blink of an eye by using divisibility rules. Divisibility rules are shortcuts or math magic tricks that help you know when a number can be divided by another number with no remainder. The rule for a number being divisible by 2 is that the last digit must be even. Because if the last digit in the number is even, the whole number is even. On your notes, fill in the area for a number being divisible by 2 so that it says the last digit is even. In 18, 8 is an even number, so 18 is divisible by 2. 22, 2 is also an even number, and so that's divisible by 2. But in 21, 1 is not an even number, so 21 is not divisible by 2. Pause the video if you need to finish your notes before you move on. Give it a shot. Is 127 divisible by 2? The last digit's a 7. That's not an even number. 127 is not divisible by 2. How about 937? The last number's still a 7. Not an even number. It's not divisible by 2 either. What do you think about 4,678? 8 is an even number. That makes 4,678 even, and so it is divisible by 2. What about a number being divisible by 5? You know when you multiply by 5, the answer always ends in a 0 or a 5. So you can tell that a number is divisible by 5 if the last digit is a 0 or a 5. Make sure to fill in your notes now to show that a number is divisible by 5 if the last digit is a 0 or a 5. Then let's take a look at these examples. 25. 25 ends in a 5, and it divides evenly by 5. 23 ends in a 3, not a 0 or a 5, so it is not divisible by 5. Don't forget to complete your notes before you move on. Pause the video if you need to. What about 10? When you multiply by 10, you know that the number always ends in a 0. So any number that ends in a 0 is divisible by 10. Fill in your notes so that it tells you a number is divisible by 10 if the last digit is 0. Looking at these examples, 30 and 340 both end in zeros, so they are divisible by 10. 67 and 784 do not end in 0, so they are not divisible by 10. Pause the video if you need to complete your notes before you move on. Do you remember the rules for being divisible by 2, 5, and 10? Let's try these out. The number has to be even if it's divisible by 2. It has to end in a 5 or a 0 to be divisible by 5. And then it has to end in just a 0 to be divisible by 10. 1,825. That ends in a 5. So it's not even. But ending in a 5 makes it divisible by 5. But it's not a 0, so not by 10. Look at 346. Which boxes do you think we should mark? It ends in a 6. That does make it an even number, so it is divisible by 2. 6 is not 5 or 0, so it's not divisible by 5 or 10. What about 510? It ends in a 0. Ending in a 0 makes the answer even. It also makes it divisible by 5 and 10. How about 1,108? 8's an even number, but it's not a 5 or a 0. Divisibility rules makes it really easy to tell which these numbers are divisible by. For these next set of rules, we look at the sum of the digits. A number is divisible by 3 if the sum of the digits is divisible by 3. That means for 135, I would add 1 plus 3 plus 5. 1 plus 3 is 4, plus 5 is 9. 9 is divisible by 3 3, 6, 9. Since 9 is divisible by 3, 135 is also divisible by 3. Make sure to fill in your notes to show that a number is divisible by 3 if the sum of the digits is divisible by 3. That same trick works for 9s. If you add the sum of the digits and it's divisible by 9, then the entire number is divisible by 9. So 369, I can add 3 plus 6 plus 9, which is 18. And you may stop there and say, I know that 9 times 2 is 18. So 369 is divisible by 9. But you could go even further and take your 18 and add 1 plus 8 to get 9. And since 9 is obviously divisible by 9, you know that 369 is divisible by 9. Make sure to complete your notes so that it tells you a number is divisible by 9 if the sum of its digits is divisible by 9. For number 6, you just have to have checked if the number is divisible by 2 and 3. Because any number that's divisible by 2, which means that it's an even number, and 3, which means the sum of its digits are divisible by 3, is also divisible by 6. So, let's look at 42. 42 is an even number. Being an even number, I would say that it is divisible by 2. If I add 4 plus 2, I get 6. 6 is divisible by 3, so I can say that 42 is divisible by 2 and 3. And since it's divisible by both 2 and 3, it would also be divisible by 6. What about 51? 51 ends in a 1. That means it is not divisible by 2. But 5 plus 1 is 6, which does make it divisible by 3. But since it's 3 and not 2, it would not be divisible by 6. Make sure your notes tell you that a number is divisible by 6 if the number is divisible by 2 and 3. After all, divisibility rules, and using divisibility will help you make listing factors much easier. Let's use divisibility to list the factors of 72. To list factors of 72, I start with 1 and 72. Now I look at my number 72. It ends in a 2. Since it ends in a 2, I know that 72 is divisible by 2. I need to figure out 2 times what is 72. I don't know how to divide yet 72 divided by 2 because it's over my basic facts. But I can think 70 can be cut in half to 35, and 2 can be cut in half to 1. So half of 72 then is 36. So 2 times 36 is 72. I can check just to make sure using my multiplication algorithm. 36 times 2, 6 times 2 is 12, and 2 times 3 is 6, and 1 more 7. For 72 to be divisible by 3, I'm going to add the digits. 7 plus 2 equals 9. I can divide 9 by 3. That means 72 is divisible by 3, and 3 is also a factor of 72. Again, I don't know the answer to 3 times what is 72. But I do know that the number has to be less than 36 because 2 times 36 is 72. I know that 3 times 10 is 30. So 3 times 20 is going to be 60. 3 times 30 would be 90. So it's not that high. It's somewhere between 20 and 30. From 60 to 72, I need to go 12 higher. So I can think about 3 times what is 12. Since I know that 3 times 4 is 12, 3 times 20 is 60, and 3 times 4 is 12. 20 plus 4 tells me that 3 times 24 should be 72. I'm going to check using my multiplication algorithm. 24 times 3. 3 times 4 is 12. 3 times 2 is 6. And 1 more 7. It looks like it's worked, so I can keep going. I have to ask myself if 72 is divisible by 4. There's not a good trick for 4s, but it's divisible by 2. And so it may be divisible by 4 because 2 times 2 is 4. I know that 4 times 10 is 40. And 4 times 20 would be 80. 72 is less than that. If I do 4 times 19, that would be 4 less than 80, which is 76. And 4 times 18 would be 4 less than 76, which is 72. If I've counted backwards properly, 4 times 18 should be 72. I'm going to use my multiplication algorithm to check. 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. It works. So 4 times 18 is 72. I'm ready to think about the number 5. A number is divisible by 5 if it ends in a 5 or a 0. 72 ends in a 2, so it is not divisible by 5. A number is divisible by 6 if it's divisible by 2 and 3. I've already proved that 72 is divisible by 2 and 3, so I know that it is divisible by 6. Just like before, I need to figure out 6 times what is 72. I know that 6 times 10 is 60. That would make 6 times 11, 66. And 6 times 12 would be 72. I can check with my algorithm. 6 times 2 is 12, and 6 times 1 is 6, and 1 more is 7. 7 is another number without a good trick, but I know that 7 times 10 is 70. 72 is only 2 more than that, so 7 is not a factor. 8 also doesn't have a good trick, but I do see that 72 adds up to be divisible by 9 because 7 plus 2 is 9, and 9 is divisible by 9. I also know from my multiplication that 8 times 9 is 72. And so 8 is also a factor of 72 because 8 times 9 is 72. Now, since my next counting number would be 9, and it's already here, I know that I'm done because the next number I would list would be 9 times 8. And I don't need to list them twice, so I have finished and I have all the factors of 72. They're 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. That sure was a doozy of a problem. Go ahead and copy down the factors of 72. And let's take a look at another example. For this problem, I need to think about the divisibility rule for 3 to decide if 3 is a factor in the following numbers. 9. For 9, I don't even have to add the digits together. It's just a 9. Since 9 is divisible by 3, 3 is a factor of 9. For 36, I think in my head, 3 plus 6 is 9. And since 3 plus 6 is 9, 36 is also has 3 as a factor. For 41, I think in my head 4 plus 1, and that gives me 5. Since 4 plus 1 is 5, 41 is not a number that has 3 as a factor. Try 321. Add the digits. Is it divisible by 3? 3 plus 2 plus 1 is 6. 6 is divisible by 3. So 321 is also divisible by 3. Therefore, 3 is a factor in that number. Divisibility is unforgettable. I hope you liked the frog theme. Make sure your notes are complete. If you missed something, go back and write it down. And go in now and complete the check problems that go along with this lesson. Remember, we will start the day by reviewing your check problems. Make sure to bring your notes as well, as your teacher will be looking for you to use them to help you as you practice in class. Have a good night.